Okay, so shall we start? It's 9 o'clock now. Great. So welcome to this session today. Just let me see if the recording is happening. Yep, the recording is happening. Okay. Okay, so let's start. Uh, see, today's topic is you should know the science behind the workflows using Git and GitHub. Well, firstly, Git and GitHub, they are an open source software used for version controlling. Now, I'll tell you more about that, when I cover the details. Okay, this is something about myself, yeah, that's my photograph, I didn't want to put it there, but Edureka insisted on that. Well, I have 18 years of experience in pure software development, and I worked for companies like Cisco, NDS, and Wiser Telecom, Lehman Brothers. And I was one of the chief implementers of the systems which you see at Tata Sky, Airtel, and many other digital broadcasts around the world. So the application which runs in your home in case you have Tata Sky and Airtel, so I'm the person who was I'm one of the persons who actually implemented that. So and currently, I'm on my own. I have a consulting and training firm, and my areas are mainly on the extreme engineering, extreme programming expertise like test-driven development, acceptance test-driven development, emerging design, refactoring. I do a lot of API design on REST. I work on Elasticsearch, and my forte in programming are in the areas of Java, C++, and Python. And I use a lot of design patterns and solid principles while writing software. Well, so that's about me. Okay. And so today's topic, what are we going to discuss? Well, I'm just going to give you a quick lowdown on, by the way, a couple of housekeeping announcements. Firstly, if you have any questions, you can just pop the question and I'll be able to see it here and I will answer it. And the next thing is, this particular session has been recorded and the recording will be shared with you, maybe in another couple of hours. So it will be available. You can go through it. You can keep it for your offline reference. Okay, so I'm going to briefly touch upon version control systems, what they are, what are the traditional version control systems, and what is Git and why Git? Why should you use Git? Okay, and the thing is that what is GitHub? And I'm going to give you some demos. Okay, I'm going to give you some demos on the Git shell and the GitHub. And also I'm going to show you some commands, what you can do with Git. So you get a pretty good introduction on what Git is and what it can do. And I'm sure it will motivate you to learn more about Git. From my personal experience, let me tell you that, I have been using a lot of, given this 18 years of experience in software, I worked on all sorts of, version control system. And let me tell you, I love Git. And since I started using Git, 6-7 years ago, I have been only using Git. I don't use any other software. And, I'm confident, I'll be able to justify why I find Git so attractive. Okay. Okay, let's move on. Okay, here we have here we have a cartoon for the funny bone. Well, it basically says, like if you don't have a version controlling system, what is the pain you have, So here is this bloke, he's writing a final doc, and then after some review, he gets another revision, which is final underscore rev 2. Then it goes to his boss, he gives his comment, that becomes the 6th version. And then, it's the 8th version with 5 comments and corrections. And finally, he keeps on doing this. And finally, at the end, he has a document version, which is huge. It has, and he says to himself, why did I come from a grad school? I mean, it is terrible, with every file name, changing, with the comments and with the reviews as it's happening. Well, all this problem, whatever this pain this gentleman is going through, can be eliminated through a version control system. Okay. And I'm sure, some point in your lives, you may have done this, this is a typical project case. You start a project, then you have a project 1.1 version, a 1.2, then you have a 1.1 May update, and then you added some functionality, some image changes, some major updates, some project final, and then some extra files added or removed. Now this is personally I feel this is a pain, because after 2-3 months you forget where things are, okay, and you won't be able to figure out where things are, and it will be a mess. So to solve this kind of a problem, we have version control system where files are versioned. Now, well, maybe because we didn't know what version control systems are. So let's see what version control systems are. Well, version control system, it's basically a software that manages changes to a file, okay? And this file can be anything, okay? It can be a document, it can be your vacation snaps, okay? It can be the code which you write. It can be practically anything which is stored on the computer, as simple as that. Now, what do you get from a version control system? What are the major use cases? Well, firstly, it saves you from creating multiple backups of your file. What we saw previously, you had some 10-15 folders with various names, and finally you'll be running out of names. So it saves you from creating multiple backups, and it also allows, multiple people to work on the same file. Say, for example, two of us are working on a piece of code, and you are doing, say, one part of the functionality, I'm doing another part of the functionality. So we can work practically on the same file. You work on a particular method, I work on a particular method. So that way, it allows multiple people to work on the same file. Okay, just before that, let me quickly have another poll. How many of you are from development background? Can we have a quick poll? Say yes or no. If you are from a development background, say yes, otherwise say no. Quickly, please. Okay, not a problem. See, it really doesn't matter whether you're from a development background or not, because whatever I'm going to cover here, that knowledge is certainly not necessary, because I'm going to tell you about the version control system. Okay, whether you are a developer or whether you are an architect, designer, or a configurations management guy, it really doesn't matter. Okay, you should be able to understand. Now the thing is, well, as I said, it allows multiple people to work on the same file. And you can also track changes, who did what, when, why. So all these things can be tracked. And you can easily have a journal, of what has gone on this particular file. And for example, okay, Paritosh, you are saying you're muted by the organizer. Well, because, since I'm not the organizer, I cannot do anything about it. What you can do, Paritosh, is you can just quickly, in the chat window, why don't you send a chat message to the Edureka organizer saying that, why are you muted? Okay. But see, the muting thing, because what I understand in the webinars, only I'm supposed to speak. Okay. Well, you may find it unfortunate, but that's how things are. Only I'm supposed to speak, and if you have anything to say, you can write it in your questions pane or somewhere, So probably that's one of the reasons why you are muted. Okay, great. Okay, sorry. I saved your time from writing to the Edureka organizer. Great. So, but Paritosh, if you have something to share, you can just write it on the questions pane. I'll be glad to answer it. Or if you have any thoughts, you can share it, I'll be glad to read it out to the other folks. Great. Let's move on. So suppose, for example, after working on a particular file and after releasing it to the customer, there are some issues with the file. There are some issues with our program. So what do? We can go back to previous versions of that file with the help of the version control system. Say, for example, I released a piece of code yesterday, and there were some problems. So I can roll back to the version the day before yesterday seamlessly, and I can just give it back to the customer saying, hey, look, okay, I botched it up. Here's your new file. You work on it. I'll work on the fix. So it basically makes you more productive. You don't have like a hunter. You don't have to go through this maze of files or maze of folders. So that's the advantage. I hope the statement of purpose is very clear, that why you need version control system. And it is mandatory, if you are doing development or if you are working with documents, even if you are a content writer, developing websites, whatever it is, make sure all your work is in the version control system. Don't think that the version control system is for the nerds or people who sit and write code. Certainly not. It can be anyone who wishes to, control his or her files. Simple as that. Okay, so just use that. Great. So let's move on to the next, the traditional version control software which we have in the market. And I'll explain to you what this client server model means. For the time being, just ignore this part and focus on this. You have some proprietary stuff, okay, like IBM Rational Clear Case. Has anyone worked on this IBM Rational Clear Case? Anyone has experience in it? Okay. Well, Joseph, you have worked on it. I have also worked on it. Personally, I don't like it. Okay. That's my personal opinion. Okay. Please don't take it personally in case you like it. So I personally, I found it pretty heavy, and pretty slow, and it consumes a lot of memory, consumes a lot of disk space, and you need a lot of expertise to use that also. So it's pretty heavyweight. Exactly. As Joseph says, it's pretty heavyweight and it's pretty network intensive. Oh, okay. These points we'll cover, what are the problems. And you have some open source stuff here, like the CVS and the subversion, like the SVN. So open source means basically you can just download, you can use it for free. If you're not happy with something, you can add a feature and give it back to the guys. And if they like it, they can include it in their next release. So that's the traditional stuff which we have here. Okay, here again, there is a question. Somebody's asking, Rahusab, you're asking, is it about what, Rahusab? Could you please complete your question? Okay, till Rahusab, frames. Yeah, it's about the, Rahusab is asking whether it's about the basics of Git. Absolutely, it's about the basics, After you go through this, my presentation, I don't think you're going to have any question left unanswered. In case there is anything unanswered, please pop your question. I'll be glad to answer it. Great, so let's move on. Now see, here we have a traditional client server model. Okay, so what is this client server model? Okay, here we see we have a repository, which is your server. Now this can be situated in your office here, wherever you are, or maybe somewhere in the United States, Europe, wherever it is. Okay, so that's your repository, your server. That's where all your documents, your code, everything is sitting. And here are the people who are working on it. So what we do is, suppose, I'm working on workstation 1, you're working on workstation 2, and our friend, working on workstation 3. So what we do is, we go to the server, and whichever file we want, we take it from there, which is called checking it out. We work on it, and after the working is done, we again check it back. So that is called committing to the repository. Now the problem with this is that you have to always be on the network. Now suppose you don't have network, or you're traveling somewhere where you don't have network connectivity. Okay, you're gone. You can't work. You're stuck. So that's one problem. Second problem is that in case there is a failure in the server, or then you lose all your work. So the guys who are sitting in the server make sure that every day or maybe every hour things are backed up in a particular backup location, so that in case the server fails, they can again restore it back. So you understand, this is a bit clumsy and it's pretty network intensive. So, and that's what ClearCase works on, ClearCase, SVN, CVS, these are all based on this client server model, as we saw it here. So, and another thing is that, okay, Gurjit is asking that, sorry, I missed some slides. May I get the PDF? Well, don't worry about it, Gurjit. The thing is that you haven't missed much, because the initial stuff was about my introduction, which I don't think is very important. You can go through it later on. And yes, you will get the slides, you will get the recording, everything you can go through it offline. Okay, here Joseph is asking, what are we doing that to maintain ClearCase? Well, in ClearCase, if you can talk to your system administrator who looks after ClearCase, they basically back up every day, or the repository is backed up. So that's a part of the IT operations which happens every day. Okay, now just let me tell you quickly one thing. Okay, now here another question, Vinod Kumar is asking, what is the use of repository? Well, repository is just like the database. That's where you have all your files. Say, for example, you're working on a particular project, And whatever is there in the project, whatever code is written, whatever documents are written, whatever manuals are written, these are all put into a database. Okay, don't think database as like Oracle or like some NoSQL stuff. Database means it's a data store. So this repository is like a data store where you have all your data, and you just take things in and out of it, as you work. So is this clear what a repository is, Vinod Kumar? Okay. Okay, now somebody's asking what are trunk, branch. So, you know, don't worry about it, Taniru. What I'll do is, I'll touch upon all these. Okay. Okay. Yeah. Joseph is saying that, oh well, Joseph is the ClearCase admin. Okay, he's taking backups, both incremental and weekly backups. Exactly. Excellent. Okay. Now, there are a lot of questions coming up. The thing is that. Uh, Okay, a lot of questions, has been asked on parallel commits and, those sort of things. Well, these things will be covered, when I talk about, because the workflows, okay? I'm confident, your questions will be asked. Okay, and somebody's asking me, can you explain to me about SVN? Okay, look, the thing is that, I'm going to not spend too much time on SVN because as you can see here, there are 26 slides we have to cover. And I would be happy if you know more about Git and GitHub rather than getting stuck with this particular software. Okay, but SVN, as I told you, it's an open source software, and its full thing is it's called Subversion. It's based on a client server model, and it has its own set of command through which you can do operations with the repository. So that's what SVN is all about. Okay, great. So let's move on. And another thing is that, while I'm speaking, I suggest that, you pay attention to what I'm saying rather than what is written on the slides, okay? Because this, whatever is written, it's for your offline reference. Okay, so later on, if you want to go through it, you can just read this. So, but for the time being, you can listen to me, and I'm assuring you whatever I'm saying is in the slide. Maybe a lot of things I'm saying extra, which is not in the slide. Okay, so let's move on. Now, as you saw, I told you about the problems. Okay, the first problem is that the repository can get corrupted, or if there are network failures, then you are not able to work. So, what is the solution? Well, the solution is that there's something called distributed revision control systems. It's called DRCS or DVCS, as some people call it. Okay. Now, the solution is something which came up around 30 years back. It's not really new. It has been there for quite some time, and now that it has come to the mainstream. Now what happens here is that let's again focus on the diagram. Okay, now in the diagram what happens is that you have the central repository, which is called the server. Okay, and this central repository, it's there, let it be there, no problem. Now what happens is, just from the previous use case, okay, here three of us were here, we had our own workstations and we were working directly with the server. But in this case, what happens is on our workstations, the repositories are replicated. Okay, I just get a copy of the repository in my workstation through a pull command. Okay, and then I work on this particular repository as if it's my local. It's like as if it's my local database. So even if there is a failure on the server, or in case there is any corruption, or it goes offline due to network outage, whatever it is, I can still continue doing my work. I can check in, check out, I can do a lot of things. And after I'm done, then I can, whenever the server is up, I can push back, my repository to the main server repository. Okay, so that's the basic model here of the distributed version control. Okay, so what happens here, basically this repository gets replicated in each of the workstations, and people work with the local repository. Once they are satisfied with this, they can commit to this repository and push it back to the main server. And while pushing back, of course, there are a lot of issues like merging and conflicts. So that I'm going to talk about later. But first, try to understand how the model works. Let's not complicate the situation. Those complications I'll explain to you as we go along. Okay. So is this part clear, this distributed version control? Can I have a quick poll? Okay, great. There is a great question from Joseph. He's asking that, how long does it take, to copy the, the master repository, which is the server, to your local repository? Well, the thing is that, if you have worked on ClearCase, it's quite a time-consuming thing that I can tell you, because if you are, taking the verbs, then, it takes a lot of time. But the thing is that, when you do it with Git, it's insanely fast. Let me tell you, I don't know what they do inside, but it works very, very fast. Okay. And Joseph is also asking that, if he's migrating his ClearCase verbs to Git, how fast is the copy, from the repositories to the, sorry, Joseph, I didn't get your question. You're asking that how fast is it to copy the repo from the server to the local box? Oh, well, I think I've answered that question. Great. Okay. Sorry, your question was a bit, okay. Okay, Taniru is asking how far is it different from DBCS? How will the sync all the users when they commit to DBCS? Okay, Gurjit, as I told you, don't worry about, don't complicate things now. Just try to understand the model, okay? The thing is that, you pull it from the main server to your local repositories and you check it in, and then again, you sync it back to the main server. And while doing so, of course, you're going to have conflicts, you're going to have merge issues, which you have to sort out manually, of course, okay? So that's the pain of merging, And let me tell you some good practices, okay? The good practices are that, make sure that you merge it with your master every day. Because I've seen people, who don't merge for weeks, they silently sit on their repository and keep coding. And suddenly one fine day they start pushing and they find that, the whole world has changed and they spend double the time, merging or, sorting out the conflicts. Please don't do that, okay? Make sure that at least, that's the discipline I followed, that I always used to, sync back to the repository, to the master repository every day, if not every day, every other day. That's a very good discipline, so that I made sure that my repository is always, in sync with the master, okay? Okay, and that's the best practice. Okay, great. Let's quickly see the questions here. Okay, some more questions coming in. Okay. Okay, great. Yeah, a lot of people are sharing their thoughts here. Here. Okay, Kiran is asking, is the merging from the local repository to the main repository, is it a manual process? Of course, it's a manual process, because in case there are merged, I hope you understand the question, other people, that Kiran is asking that, is the merging from the local repository to the master repository, is it a manual process? Of course, it's a manual process. Obviously, there is a UI for that, but in case there are conflicts in merging, you have to sort it out. So the software cannot decide on your behalf. Then it will be suicidal. Okay. So this is about the distributed version control system, and this is very important because the Git model is completely based on this. Okay. Great. Let's move on. So welcome to Git. Right. So let me tell you a brief history about Git. It was initially developed by Linus Torvalds. Now Linus, he's the guy who created Linux, and his design philosophy was very simple. He wanted something which was free and open source. He wanted something which is blazingly fast. Okay, blazingly fast. And if you work on Git, you will understand how fast it is. It should be distributed so that people did not depend on the central server. In case of network failures, people could still continue doing their work. And obviously, he wanted data assurance. By data assurance, I mean that data integrity. Okay, data integrity means that the repository which you have is always in sync with the repository which you have in the server, and they are, there is a mechanism called checksum comparison, which makes sure that files don't get corrupted. Okay, so that's what I call data assurance. Okay, now Ajit is asking that, is there a problem in sharing my local repo with a team? Definitely, there is no problem, and I'm going to touch upon that feature. that, okay, Ajit is asking that, can I share my local repository with somebody else? Of course you can. You are encouraged, because that's how code reviews happen. And I'm going to touch upon that. Git gives you a, mechanism to do that. And the best part about Git is that, you don't need code review tools, because I've seen that, version control systems, don't come with code review tools. So if you want to review somebody's code, you have to use something else. So, but here with Git, the advantage is that, you can just use Git for code review, for version controlling, for, tracking issues in the code, just like a bug tracking system. A lot of things can be done. It's so flexible. Okay, so that's the philosophy of Git. Okay, here Kalpesh is asking, does DVCS, does Git maintain the complete file or just changes to a particular file? Well, it maintains changes to the file, of course, not the complete file, because then, obviously your local repository size will increase. It has efficient algorithms just to track the changes which is happening. And when I show you the UI, you will be fascinated that how beautiful it is. Okay, great. Now let's look at quickly how, Git can be configured. Let me tell you, Git can be configured in several ways. Okay. It can be configured. You can use it as a classic client-server model, where you have something, as a shared repository, and all the developers, work on it like a shared repository. Okay. Okay. Somebody's asking that, can we use our system as a Git server instead of using GitHub or any other repository system? Okay. No, the thing is that, yes, you can use your system as a Git server, not a problem. But you have to just set it up as a repository and do some configuration changes so that the GitHub knows that the repository is lying in your particular machine. Okay, somebody's asking, do I always need to use source tree Bitbucket with Git? No, not necessary. You can just do it with command shell. You can do it with UI. It's your choice. Okay, it's not necessary. Okay. Okay. Kaustav is asking that in Pervos, we can shelve our code without submit. Is it possible in Git? No, it's not possible, Kaustav. In Git, you have to commit the changes, and you will see why. Okay. And again, somebody's asking, is it necessary to have a Git account? Well, I'll touch upon that. Things will be pretty clear once I touch upon. Okay, I suggest you hold on to your questions. First, please try to understand how the deployment model happens, because that's very important. In your, it will guide you to decide how you want Git in your organization or in your projects. So here you have a classic client server configuration where you have a shared repository, and as I said, developers directly work with the repository. Okay. Now, the next configuration is something called a typical open source configuration. Here, what happens is that you have the blessed repository. Okay, this is the main repository. But developers like you and me, we cannot do anything here. So what we do is, we have our repositories here, public repositories, and here we have our local repositories. So what we do is, we basically, there's an integration manager here who basically checks out and checks in only from the blessed repository. So he's the only person who can touch this repository. So he pulls in, and we all developers get the code from him to our public repositories. Okay. And then we pull it to our private repositories, that is in our local machines, work on it. And after the work is done, we publish it back and then tell the integration manager that, look, something is available here. Why don't you take a look? And if you like it, you push it back to the blessed server. So here the integration manager acts like a gate. Okay. And this is how typical open source works. If you are an open source contributor, you know how it works. This is exactly how it works. So I check in something, in my public repository, and I notify the integration manager that, hey, look, I've done this particular bug fix. Have a look. If you like it, push it back to the open source. So that's how it works. The third deployment is the Linux style. Okay, that's how Linux works. It's basically very similar to this. It's very similar to this. But what happens here is that in between the integration manager, there are subsystem managers, which are called lieutenants. Well, these are just fancy names. Okay. Now, suppose you have a big system. Now, the big system, will have subsystems. So what happens is, there's a subsystem 1, there's a subsystem 2, and we developers, maybe I'm only interested in subsystem 1. So what I do is I directly take the code from, say, the Linux server. I take the code, I do the changes in that particular subsystem, and I notify the integration manager for that particular subsystem, saying that, look, this is the changes which I've done. If you like it, you can push it forward. So if the integration manager likes it, he then sends it to the chief integrator. And if he likes it, and if he's fine with that, then he pushes back to the repository. So that's what happens with another developer. If he's working on, say, another subsystem, he can take that code, do some changes, give it to the lieutenant of that particular subsystem, and he in turn can push it to the chief integrator, who pushes it back. So that's how Linux works. Okay. Okay, Ajit is asking, is pull request like imitating? No, it's not, Ajit. It's not. The integration manager's job is completely different. Okay. Pull, anybody can actually pull. You and me can go and just pull a repository. That's not a problem. But that doesn't mean that we can push it back, because that's only the integration manager can do. Okay, Gurjit is asking that. Yeah, Gurjit is asking that, is the code review done simultaneously in the subsystem before going to the main repository? Absolutely, Gurjit. You can do it in your subsystem before it goes to the main repository. You can say, for example, you wrote something and you just invite me to have a look at your code, and I can just have a look at it, and I can review, I can give my comments, and you can incorporate that, or you can reject it, whatever it is, and then just push it back. Okay. Okay, Sai is asking, does integration manager clone the repository? Well, not necessary. It depends on the requirement. If I want, I clone it. If I don't want, I don't clone it. Developers cannot. Kapil is asking that, can developers pull from lieutenants? Yes, you can. See, I'm telling you something, guys. You can pull from anybody you feel like. Okay, you can pull from anybody you feel like. But for pushing, it depends. Okay, here the situation is like, I'm pushing, but it depends whether he would like to review that. He can reject it, or he can even push it forward. Okay. Okay, now Paritosh is asking, is there a difference between collaborator and integration manager? Well, there is not. Well, these are two different words. I mean, it depends. And I can be a collaborator as well as an integration manager. It depends what you want to be. Okay, somebody's asking, what do you mean by the blessed repository? Well, blessed repository means that, that's where all the stuff is, which is deployable. Say, for example, the GitHub software, which you use, which you download from the website. So wherever that code is, that is the blessed repository. That's where all the production code is. Okay. Okay, Gurjit is asking that Git is open source, but can he use it for his startup? It is very secure. Don't worry about that, because I know companies who use GitHub for a very long time, and they are all startups. And in case you become a big organization, down the line, you can always take buy an account, having a private repository, that you can always do. Okay. See, okay, another thing, sorry to disappoint you, I'm not going to answer any questions on the syntax. A lot of people are asking me, what's the command to integrate my code? See, let me tell you something, this is not a course. This 1 hour is not for you to learn the GitHub commands, not for you to learn master GitHub. Okay, please bear this in mind. Let's get the scope very clear. This 1 hour is just for you to understand how you will benefit from GitHub. Okay, why you should use GitHub. And please don't ask me, refrain from asking questions like, what's the command line? How should I go about solving this production issue? Because this is not the GitHub course. For that, I suggest you sign up for the GitHub course, and all your operational issues, will be crystal clear. Here in this particular session, I am here to convince you that GitHub is the right way for you. Okay, folks? Great, let's move on. Okay, somebody's asking, all repositories are public. Well, public repositories are repositories which you want to make it open source, or if you want to use GitHub for free. If you want a private repository, you have to pay them. As simple as that. Okay, I think, let's put a pause to the questions, because I find a lot of, uh, a lot of questions have been asked on implementation. Well, guys, bear in mind, this, as I told you, this is not a course. Okay, this is an introduction. So don't ask me, commands and things like that, because you may be taking a lot of airtime, which can be used otherwise, in showing demos. So please be considerate on that, as well as on the other people who are in this webinar. Let's move on. Okay, so I hope these deployment models are very clear to you, because don't worry about command lines or commands. Make sure that you understand these three models, because that's how you're going to implement in your startup or in your organization or team. Okay, great. So let's first understand how the Git repository structure is. Okay, now before I go through this text, let me show you a diagram. Okay, this is very, very important. You have to understand how Git repository structure is. If you don't understand this, you haven't understood Git, anything. So first thing is that the Git repository, whether it's local or in the server, has basically three partitions, okay? The first partition is called the working directory. Now that's where basically you are working, where you're doing changes in your code, okay? Once you have done, once you're working in the code and you feel that, okay, fine, I'm happy with it, you can add it to the staging area, okay? So that's a git add command. You add it to the staging area. And once you are happy with the staging, and that this is the area where you have all your code reviews, where you can invite people to look at your code, give you comments, okay, and things like that. And well, you can do it in your working directory also, not a problem. But usually what people do is, what usually typically I do some changes here. I invite people through pull requests. They come here, they give code review comments, and once I incorporate that or whatever, reject it, whatever it is, I put it to the staging area. And once I am happy with the running the tests and everything is fine, then I finally commit it to the repository, which is my local repository. Mind it, not the main server. This is my local repository. And once it's fine, and once I'm on the network, from this local repository, I push everything to the master repository somewhere in the World Wide Web. Now, somebody might ask me, why do I need the staging area? Okay, I can directly from working area, I can get code review comments, test it, and boom, I can directly put it here in the repository. Why do I need this staging area? Well, the biggest advantage of staging area is that, say for example, you're working on a particular file and you change one part of the file for say customer 1, okay? And you have to change another part of the file for customer 2, and the change which you did for customer 1, customer 2 doesn't want it. So what you can do is you can do the change for customer 1, you get it reviewed, and then you add it to the staging area. That's gone. And then you start working on the customer 2 requirement, okay? So that does not impact what you did for customer 1. So this staging area also helps you in isolating, the work which you are doing. Okay. So I hope this part is clear, right? Great. Okay. Somebody's asking, how can we invite other people for code review in the staging area? Well, see, the thing is, this working directory, staging area, repositories, these things are transparent to the users, okay? These are basically the internals of Git. So this is what happens. So basically when you do a Git add, it basically goes to the staging area. When you do a Git commit, it goes into the repository, the local repository. You directly, don't interface with the staging area repository. These things are transparent to you, okay? And you can invite anybody for collaboration anytime in any of these areas. Doesn't matter, okay? It's just that, if something is wrong again, you have to roll back things, okay? Okay, somebody's asking that, okay, somebody's asking that is the staging area is the other sub branch like stage branch? Well, this question, sorry, Ankur, I didn't understand your question. Can we authorize repository for only particular users? Yeah, you can. Somebody's asking, can we authorize repositories for particular users? Yes, you can. You can, do that. You can add roles to that. That's possible. Okay, so whatever I said in the last 5 minutes, this it's kind of summarized here. Okay, you can read it at your convenience. And this staging area in Git parlance is called an index. And the last commit which you made goes to your local repository, which is usually called the head. Okay, these are basically Git terms. Great, let's move on. Let's see GitHub now. Okay, so GitHub, it's basically it's a web-based Git repository hosting service. Okay, so if you want to create a repository, you go to this GitHub and you create a repository. And there, as of today, there are more than 28 million repositories. Let me show you my repository. Okay, so if you go to GitHub Prithviraj Bose, so that's my repository. Okay, I have all my open source stuff here, where I give it out to people to use, and these are my repositories. Okay, now all these repositories are public. Let me tell you, by default, you can create an account here. It's absolutely free. You can go and sign up. All you need is an email ID and a password. You create a repository, and they are all public by default. Okay, if you want a private repository, like if you're working in an organization and you don't want other people to sneak into your code, then you have to pay them. Okay, so you can buy space, and they have these plans, so you can buy that. Well, since I am an open source guy, I all my repositories are public. I don't have anything in private. And I cannot tell you much about private also. If somebody asks me, what is the price or how do I go about, well, these are all automated. You can just go there, select a particular plan, and just go ahead with that. And here you can give access to people, who can view this. So I hope that answers Sai's question. Great. So this is how the repository looks, and you have individual repositories. I can just click on a particular repository. Okay, and basically, I can add whatever I want here, and I'll go through the specifics later on. Okay, I'll explain to you these things later on. So this is how a repository looks, and you can click on the directories. You can click on the things. You can see the code here. Okay, and you can see all the history behind it. And when I was talking about data assurance, you remember in the previous slide, this is what it is. This file has a particular checksum. Okay, so this is what makes sure that this file is not corrupted when it is merged back to the server. Okay, so here's my repository. Now, okay, so let's move on. And it provides beautiful features, like code comparison, code sync, and Git shell. This I'll give you a live demo on that. Don't worry about these things here. I'm going to give you a demo on this. So I think when you see it, all your doubts will be clear. Okay, now here we see that let's see a typical day, with Git and GitHub. How are you going to use it? Okay, just follow this diagram. What you do is you see the main line here. This is what we call the trunk. Okay, this is your main production, whatever documents or source code you have. So this is what you have. Now suppose you are going to work on a new feature or a new document you're writing. If you're a content developer, what you do is you go to this main trunk, and from this trunk you branch out. Okay, and this becomes your branch in your local repository. Now after branching, what you do is you do some changes here, you do some changes to the file, and you commit. So after you commit, then what you do is you submit a pull request. So this is the sign symbol for pull request. Okay, by pull request I mean code reviews. Okay, so this is the point where you can invite a code review. And as I said, you have done a commit. Okay, so that means your file is in the staging area. Okay, and now you are inviting somebody to have a look at it. Great, so let him look at it and let him give you your comments. And the review session goes on, so you exchange comments and whatever it is, do some changes. And once you're happy with that, you again commit it back, and then you deploy. And by deploying, I mean that you put your particular branch on the production line and see whether things are working fine. And once things are working fine, then you do a merge with the main trunk. And while doing a merge, you will see that the files or the documents which you worked on may have been branched out by somebody else also. And there will be conflicts, of course, because that person did some change here, you also did some change here, and when you're merging it back, and suppose that this person has merged yesterday, and now you're merging it back, there will be some conflicts, of course. And you have to manually sort out those conflicts, either by talking to that guy or by going through the history and you have to merge the conflicts. So I personally, I'll give you the best practice, just make sure that, these things, don't take more than a couple of days, okay? Just make sure that, you frequently, sync with the main line as frequent as often. Otherwise, if you're doing this merge after 1 month, I'm telling you, you will spend another 2 weeks, just resolving this conflict. So it will be just a waste of time. So make sure that your branch, what I used to do every morning, I'll tell you, when I used to go to office or even today, when I work, I basically just quickly do a sync with the main branch. I have my branch. So I quickly do, pull everything latest from the trunk to my branch. And while doing so, if there are any conflicts, I resolve those conflicts and then I continue working. Once I'm done, tested, and I'm happy about it, I check it back. And please pay attention to these icons here. This icon means that you're branching. It's very clearly evident, no? Like, you're branching out. So this means branch. This icon means pull request, okay? So pull request basically means that you have a main line here, you're branched out. So you're pulling in somebody, to have a look what you have here. Well, deploy here, the busy squirrel. And of course, the merge, it's just the opposite sign of what you had in branch. What you have here is going back to the trunk. So I hope, this is how a typical day is going to be for, for somebody, using GitHub. Okay, Gurjit is asking, would someone, Gurjit is asking that, rather than asking him, can somebody override the code? Well, he can. It's not necessary. Suppose Gurjit, I'm merging in and I have some conflicts with your file. Well, the best way is that, I give you a call. And if we are in the same office, I just call you over or I go over to your place. In case, we are across different cities, then I just give you a call and we try to sort out things. But usually that doesn't happen because, say, for example, Gurjit, if you are sitting somewhere in Amsterdam, it's not possible for me to call you, right? And there may be time zone differences also. So what I do is, I go through the change logs. I try to understand what you have done. And then I try to intelligently merge it. And if I screw up in the process, well, that's my fault. Gurjit, that's not your fault. It's my fault. I can screw up. Okay? So that's the thing. Okay. Okay. Now somebody's asking that, there's something called a tag concept. The tag concept, you can actually do it while you're committing. You can give a tag and you can commit it back. So you can give it there also. You can create tags in your pull request also. You can give tags while review also. That's up to you actually. Okay. Well, you can see the thing is that you have to understand one thing. A lot of people are coming from the client server background, and we use terms like check-in and check-out. Well, let me tell you something. In distributed systems, please pay attention to what I'm saying. This is very important, okay? Because for the last X years, we have been doing check-in and check-out. Concept of check-in and check-out doesn't exist in Git, okay? It doesn't exist. What happens is in Git, when you get a local repository, it automatically means that all files are checked out. You can do whatever you want with them. Is this concept clear? There is no concept of checking in or checking out. So whenever you get a local repository on your system, everything is checked out. You can just do whatever changes you want. But if you want the changes to go back, you have to do a commit for the changes you have done. And when you do a commit, basically it goes to the staging area internally in the Git. And then you can call people to have a look at what you've done. Is this concept clear? Quick poll, please, yes or no. Is this concept clear? Great. Because, I find a lot of people, asking this question that, what do I do? Check in, check out. This is absolutely fine. This question is absolutely valid because if you have a background of client server, I think you have to unlearn. You have to unlearn a lot of things. Okay. Fine. Let's move on. Now it's time for some demos. Okay, great. Now somebody's asking quickly. Let me take the question. Any lock we can hold on file during checkout? Okay, Kezia, as I told you, no concept of checkout. checkout doesn't exist. Your local repository is everything is checked out. Clear? Yeah, you can create multiple branches on your own. I'll show it to you. You can create as many branches as you want. It's your call. Okay, fine. And by the way, I'm not going to answer any questions of Git versus Bitbucket, Git versus CVS, Git versus other software, because I don't think it's going to be very useful for the other participants, because I think we don't have much time. I think let's see some demos, okay? Because whatever questions you're asking, I think you can just do a Google search. You will get loads of questions on Stack Overflow, okay? And check Stack Overflow, for comparisons. Please, let's not waste air time on doing these things, okay? If you don't mind, because I'm sure other participants would be interested in seeing the demos more than getting these comparisons which you get on the net, easily. Great, let's move on. Okay, so this is my GitHub, okay? This is what I have here. And what you do is you can download two software. The one is called the GitHub UI. This is the UI which you use to interact with the Git repository, okay? And let me close this, I'll show it to you later. And there's something called a Git shell, okay? Now Git shell is basically just a command line interface for the UI. In case you don't like the UI for some reason, you can just use the Git shell. Not a problem, okay? So let's quickly go to the GitHub. Okay. Now here you saw my repositories, right? These are the repositories I have, and I can, and basically the same list you see here. So this is my GitHub, and these are the repositories I have, my public repositories. These are listed here. And in case you want to, get the repository, there's something called a sync. The moment you do a sync, you can sync whatever you have on the server with whatever you have here, or whatever you have here with whatever is there in the server. So those things I'll show it to you. Let's first understand the UI. Okay. So say for example, let's take my folder Elasticsearch. This is a repository I have here on this is my local repository. Okay. And this is what I have here is my public repository. Okay. So in my local repository, I have two tabs, changes and history. In the changes, it basically shows that, what changes I've done locally. And these are the files it shows, 6 changes I've done here, which is still not committed back to the server. And in the history, if you go, this is the beauty of it. In the history, what you see is, you will see that what I have done over the days. Okay, so here basically the first thing 2 days ago I committed, I did something here. Then I created a version 1.1. So this was my Python file, where there's a lot of code for Elasticsearch. And then just a day ago, I created another version. And the beauty of it is, it just shows here what changes I did on this particular Python file. So here, if you see, the red line means, it's gone, deleted. And the green line means that line is added. Okay, I made a mistake here in the spelling of convert. So I wrote it as covert. So what I did was, I just corrected the spelling. I just changed the covert to convert to, Elasticsearch JSON. And, I did some changes. So everywhere, wherever covert was there, I just changed it back to convert. Okay. So there was a typo and I just, I just fixed those typos and then I checked it in. So here, basically, you can see the history. Okay. And if you take a big project, so here, if you go to the history, so actually it shows you all files, what you had committed back to the server. So it shows you all the files, like what you checked in, and in case you did any changes, like in the red and the green, it will show you the changes here. So this is what, the changes and the history means. Okay. And here, basically, it shows you the branch and the master. So basically right now, Elasticsearch has no branches. It has only one master. And this is the master here. Okay. And so that's it. Now what I'm going to do is, let's quickly go through a demo. I've made a nice list of demo here, and I'm going to show it to you. Okay, Git demo list. What do we have here? Let's see. Okay, creating a repo. I want to create a repository. Now guys, pay attention to this, okay? I want to create a repository. So what you go is you go here on the plus sign. You have something called a add, you have something called a create, something called a clone. Add repository means that you already have a Git repository from somewhere you got, and you just want to add it to this UI. Well, that's it. Clone means basically if you want to, all these things which we have here, if I want to make a copy of it and, work separately on it. Create means that I want to create a fresh repository. And I'm doing this because, this clears a lot of concepts. Okay, I'm going to create a fresh repository. And so what I have a file here, and I have something, like for today's session, I have something called, okay, a local path, git test. And I have a project. I want to create a project. Some time back, I did a project on the analysis of the Indian Railways timetable. Okay, if you're interested in that, you can go through you can search on the internet. So the Indian Railways timetable. So I did a data analytics on that using R. Okay, there's a language called R. So I use that using R. Okay, and so this code is residing in Indian Railways timetable. Okay, I create this particular repository name, and git ignore. Don't worry about all these things now. This. So just as it is, you just create the repository. Okay, so the repository is created. Bingo. Now what we are going to do is, as you can see, so if you go to the changes, you will see that there's a file here. Okay, there are two files here. One markdown document I have, which basically, describes what I'm going to show here. And there is this main source file, R markdown document, where I have all the R source code, which does all this data analysis on the Indian Railways timetable. Now what I'm going to do is, these are the two files I have, and I want to, publish it. I want to make it public. So here's a button here, and I click on it. Okay. When I click on it, the name shows, Indian Railways, and I give a description. I say analysis of the Indian Railway timetable. Okay. And from here, I can select my username. And as I told you before, if you want private repositories, there are some plans here. You can just go through it. And I say publish. Bingo. So what it's going to do now, this repository which I have, it is now putting it in my GitHub here. Okay, it's going to put it here. So let's see. Okay, it is publishing, and after publishing, you will see, it takes some time for syncing. So after this, the button will change to sync. Yeah, the button now changed to sync. So sync here means that if I now go here in Prithviraj Bose, and if I go to repositories, okay, I find this is here, updated 23 seconds ago. I created a repository. Great. I go here and but okay, fun now. I don't see these files here. Okay, I just see the repository. That's all, no files here. Well, the files are not here because the files are still in the working directory, and you haven't added that. You haven't added that to the staging area. You haven't added that to the head, and you haven't published it. So what I'm going to do, I'm going to take all these two files here. Okay. And you can actually select which change you want. Suppose I just want to check in this, just want to upload this. You can just select on that. But here I want all the files to go, so I do a select all. And here I say version 1.0, and I write some test, some description here, and I say commit to master. Okay, it's committed to master. Now when I committed, it has gone to my local head. Okay, it is still not there in the server. To put it back in the main repository, I have to again click on sync. So now it is syncing with the main server here. And once it is done syncing, you will be able to see the files here. Okay, let's see. Now it is syncing. And once the syncing is done, okay, the syncing is done. So hopefully we should be able to see it here. Bingo, I have it here. Okay, my README files. Okay, and my analysis file. Great. So this part is done, and as I told you also, pulling from the repo that I already showed you. So, and by the way, this GitHub UI which I'm using, it comes with Git, so you can go to the GitHub UI site and just download it. It's a part of the Git software. You can actually, you can do sync the code, just click any of the repositories, and if you click on sync, suppose someone else is working on it and they did some changes. So if I want to update it, I just go and click on sync. So whatever is there in the main server in the World Wide Web will come down. And in case if I have any conflicts or merge issues, I have to sort it out. Okay. Great. So now let's see, adding files I already showed you, committing changes that I showed you, pushing the code I showed you. Now let's do the most important thing, let's create a branch and do a merge. Okay, so I'm working on here. Now I want to create a branch. As I told you, the symbol for this branch, okay, I create a branch. Okay, my branch is test branch. Okay, I see a test BR and I create a branch. Great. So now I am viewing the branch and these are the files which I have here. Let me quickly do some changes. And as I told you before, that there is no concept of check-in, check-out. Here everything is checked out. So I go to this file here, I open this R document, this R code, and once I open it, so okay, here is a comment here, getting a hang of it. I just change this command to I am ready and I save it. Okay, and I close it. Now if I go to GitHub and if I see the changes, sorry, Indian Railways, if I go to the changes and if I click on the RMD file, I'll see that, okay, there was a getting a hang of it. Now it has become I am ready. So I deleted this line, added this line. Okay, and let me check in this to the, okay, sorry, let me go to, oh, I'm so sorry. I created a branch on the thing here. Okay, sorry about that. I should have created it here. So let me quickly create a branch here. Okay, I create a branch here. Okay, and in the master, I'm seeing that I've done the change here, and in the test branch, I'm in the test branch now. I just revert it back. Well, I'm ready. I just add a text, so are you. Okay, and I save it. So now what happens is, so now I'm in my test branch. I'm saying, getting a hang of it. I am ready, so are you? And in the master, I have, I am ready, so are you. Well, now what I'm going to do is, I'm going to take the master, okay, and what I'm going to do is, I'm just going to create a version 1.1, and I say commit to master, okay, and I do a sync. So now you see, this progress bar here. So whatever, changes which I did, it's syncing to the server. Okay, now it's synced. So let's quickly go there and let's go to this, and you will see two branches here. Okay, sorry, one branch, because the test branch I still haven't committed. So if you go to this document here, okay, you will see that I am ready, so are you. So this comment has come here. Okay, now what I'm going to do is I'm going to go to GitHub. I'm going to take my test branch. Okay, and in the test branch, I'm going to first have to do a publish. Okay, but before doing any publish, what I want to do is I want to do some changes. So I open the document. Okay, and here it is still showing getting a hang of it, okay? Because I'm in my test branch. So I want to check this particular thing in, okay? I want to change the comment. Now if I go to GitHub, I'll see that, I added 2 comments here. And let's do something. I want to first, publish this particular branch to my server. So I'm now publishing the branch, and in the meantime I can create another version 1.2. So as you see, this UI makes your life pretty easy. And while this happens, I can, and you see that it has been done, okay? And if you go here, and if you just click on this, and you will see that now, sorry, if you click on this repository here, you will see that test branch is also here. Okay, test branch is here. And in the test branch, you will see that it is still the old document which I have, okay, with one semicolon. But I have added 2 semicolons here, right? I have 2 exclamations, I'm sorry. So I'm going to create this version here and do a test, just submit. And after submitting, I'm just going to do a sync. So this, whatever is there in the local repository, is now going to the main repository. So let's see what happens there. So it's still syncing. So if you see the syncing here, well, it's done. Now let's go there and quickly go to our railway stuff and quickly see the test branch. And let's see this file. Okay. And let's see the RMD file. Bingo. There are 2 exclamation marks here. So it's updated. Now I want this document to go back to the master. I want to merge it back. I have to do a merge. Okay, guys, pay attention now. Here, if you see, here is a main line. This is the trunk, and this is your test branch. Okay, and if you see here, at this point, you have created a branch. And if you click on this particular node here, it shows you that what changes you did. Okay, that's the beauty of it. It's so illustrative. And at this point, it says that you actually published. So this signs means publish, and these signs means a commit. Okay, so this means I committed at this point where I did this change, and here basically I published. So once the publishing is done, now I have to merge it. Merging is very simple. What you have to do is just click on update from master. Okay, and what you do is you go to the master, you click on compare test branch, and you say update from test branch. Okay, so if you do this, so basically whatever is there in the test branch will come to the master. And if you go to master, okay, and if you go to the test branch, and if you do a compare with master, and you can actually see the comparisons here. And if you do an update from master, then basically it's going to get everything from the trunk. But here we are going to do the opposite, right? So we select the master, we compare it with the test branch. We have seen what changes we have done, and we say update from test branch. So we are updating. Okay, so there are some conflicts. Great. So let's view the conflicts. What is the conflict here? Okay. So what you have to do is, in case there are any conflicts here, okay, so what you do is you see that this commit is here, so whatever you want, you commit it back, okay, and then you do a sync. So as you can see, it is syncing. So once the sync is done, let's go back to the master and see what's happening there. Okay, so we are now in the master, we merged it back. Now let's see what it is. Okay, so you remember what I did, I just reverted back because there was a conflict. So I got back what I initially had. Okay, and then basically it added, because I kept both the changes. I did not delete anything. I could have either kept this one or kept this one. Just for this example, I kept both of it. So the initial comment is here, as well as the changes which I did from the master. That also I kept. In case I didn't want that, so I had to physically go here, open the file, and just delete the stuff which I don't want. Okay, so that's about the merging part. And somebody's asking about the UI interface. Sorry, about the command line. And what you can do is you can always right click on it and open the Git shell. Okay, so whatever I did here using the UI, you can do it over the over the shell. And these are some commands which I've given you, which you can use. Okay, say for example, if you firstly, if you open this Git shell, you need the Git, and then you add the files, whatever you want. Star is a wildcard. You can give the names, you can commit and give the labels, and then finally you push it to the original master, which basically goes to the main repository. And I deliberately did not want to use this shell here, because at times my last experience says that this typing a lot of people could not follow the, like if I just give git status, it shows the master is up to date. Here the problem is a lot of people could not follow or could not see what's going on. So that's why I refrained from using the shell. Okay. Well, you are saying, yeah, Git shell is a Unix shell. Uh, well, basically, see, if you want it on a Linux shell, you can, because I have got a Windows system. So Git, if it's a Windows installation, Git gives the Windows shell, the PowerShell. So if you're on Linux, you will have your Linux shell, or you can have an emulator like Cygwin or something like that, where you can have your emulators. Okay. So that doesn't matter, just because this is Windows in Windows shell, you can, in Linux, you will have your Linux shell. Okay. Well, for enterprise topology, you will have some logins, like here when I published, it was pretty straightforward. I just selected Prithviraj Bose, but if it's an enterprise scenario, then you will have a login screen, and it's just like when you log into a website. So those things are taken care of. Okay. So well, that's the thing, and then I come to the pull request. The pull request is basically that's when you do, say for example, well, I don't have any changes here, but suppose I want somebody to look into this JSON file I have, and what I can do is I can create a pull request here, or maybe, okay, let's use this example now. Say for example, whatever merging I did, I can create a pull request. So this basically tells for a code review, somebody can come and give me their remarks, and I can add people. Right now, I no one added here, but you can actually there's a place where you can add people, and you can send the pull request, so they can actually exactly view this particular branch of yours, whatever is going on here. And you can write the issue number or the review and the descriptions, and just send the pull request, and whomever you send it to will start reviewing your code. And you can actually track it, as the pull request happens, you can see all the status here. So that's a pretty useful feature of it. Great. So this brings us to the more or less end of it. And let me quickly tell you about something about the course. Okay. Okay, somebody's asking that, so each time you access a repo, which will get on the repo, and there is no need to check out code. Whenever you get the repo to your local system, everything is checked out, Nicholas. Okay, now course details. There is a batch which is starting on the 17th of October. Okay, and I suggest, if this excites you, I suggest you quickly, maybe tomorrow, day after tomorrow, just go and register yourself. And it's a great course. A lot of questions which you're asking here are actually covered here. So because as you understand, it was 1 hour, and now we are 1 hour 15 minutes into this, and I can go on talking. But as you appreciate that, I cannot answer all the questions because time doesn't permit. And so, I suggest you take this course up, and whatever questions you have will be gradually answered. Okay. Okay, and so, well, that's about it. That's it from me. And if you have any questions, I hope you found this useful, this particular webinar, because see, the main purpose of this was, why you should use Git, and rather than doing comparisons with other software, which you can really find it on the internet. Frankly, you don't need to register for a webinar for that. But I hope you're convinced that why you should use GitHub and what are the benefits. You got a sneak preview of the UI interface. If you like using command prompt, you can use the shell. So, and I showed you also, what are the things you can do here with GitHub. Well, I just give you the tip of the iceberg. There are a lot of things you can do, which I didn't show because of lack of time. Well, that's it from me. And so I think we can call it a day here. If you don't have any more questions or burning issues, then I can close the call. And what you can do is, you'll get the recording and the presentations. Everything will be available to you within 24 hours. Please give me your feedback, your questions, queries. Send it to the link which will be provided to you. Okay. Somebody is asking, can you give a short description about the issues and the importance? Okay, the issues and the importance, like your question, Paritosh. It's a 3,000 feet question. Like what issues are you talking about? Like issues of GitHub, or issues of Git? See, I'll tell you, I'm using GitHub for the last 8 years. I did not face any issues. I'm pretty happy about it, and that's one of the reasons why I'm doing the webinar. And importance, as I told you, it has a distributed, it's a distributed model. So a lot of the problem shortcomings of the client-server model is kind of circumvented. It's overcome by Git. And as I told you, it's insanely fast. Okay, when you start using it, you'll realize how fast it is. Okay, okay, you're talking about issues. I'm sorry, I did not answer you, understand your question. See, the thing is that creating issues in the sense, as I told you, you can do it through a pull request, and the thing is that you can go to the web here. You will see that there are ways to create issues here. There is a link here. So you can create issues. You can assign it to people. Those things you can do. So that's basically the place, and you can track it through the repository in the UI here. Okay. Okay. Now. Okay. Okay, yeah. Rajesh is asking, can we use diff for previous versions? Yes, you can. You can do that. You can do a diff with that. And well, no, Nicholas, GitHub doesn't connect with Docker Hub. I think there are connectors available which you can use. Okay, now Taniru is saying there are no drawbacks in Git. Oh, well, he or she, I don't know, is amazed. Well, I told you, it's just my personal opinion that I did not find any issues. That doesn't mean that there are no issues, maybe if you find some, let us know, please. Okay, great. So thank you very much for your time, and I think we'll end the discussion here. It was a great discussion. It went on for nearly 1 hour 20 minutes. Okay, and well, thank you very much. Have a great day wherever you are.